Hello everyone, welcome to this new video where we'll see how we can create complex PDF RAG agent using QueryPipeline, which is given by LlamaIndex. So as you see in the last video, like how we can create different agent using LangGraph, which can be a sequential or cyclic agent, which will run until they complete the job. Similarly, LlamaIndex also provides you an option to create such agents using QueryPipeline. So we'll be creating one agent which works pretty well on the complex PDF. So it can answer questions from complex PDF, either it's the question or the answer is given in the tables. So in this video, we'll use three different complex PDFs, and we'll try to ask different complicated questions to the large language model and see how we can get the answer. So this is the complete architecture of my PDF RAG agent. So how it works is like it will pass the input, then it goes to generate sub questions. So like input query could be a complex query. So first we want to generate sub questions, and then we'll just have a decision node which decide whether I want to retrieve the table or text together, or I want to just retrieve the context from the table only. And then from there, I just go on to generate the response from the LLM, and then there's a response synthesizer. So this is how like my agent will look like. I've just designed a sequential agent, but you can design a cyclic agent also. So next, what we'll do is go ahead and install all the required packages. So I'm just doing that. And these are the three financial PDFs which will download: one for Uber, second for Lyft, and third is for NVIDIA. And we'll be asking questions from these PDF documents. Like in one query only, I will try to get an answer from all the three, all the two PDFs. So we'll see how we can do that. Next, what we're doing is like we are just importing secret keys, which will be used. Like we have to pass the secret key for Hugging Face API also, and also for LlamaParse. Then just importing those packages, and then this is one way of like inferencing the model. Instead of downloading the model locally, you can just use the Hugging Face inference API, and whichever models are already hosted by Hugging Face, you can just do inference on this. So I'm using mistral 8x7b model, which is a big model. We need bigger GPU to download it, but I'm just using this inference API. You just have to pass your secret key from Hugging Face, and then it will work for you. If you don't want to use this Hugging Face inference, you can just download the model locally also. Just I have given the code, just uncomment this code and run it. It will download the Zephyr model, as we have seen in the previous video also, and it also works pretty well. Then I'm just downloading the embedding model, BG based embedding model. And then here I'm just calling LlamaParse by passing the secret key, and it's just parsing all the three PDF documents what I have. And then I'm using markdown element node parser, and I just did some modification as I've shown in my previous video also. Like I don't want to create summaries through LLM. Without summaries also it works pretty well. So here I'm just calling the instance of this markdown element node parser as node parser, and I'm just passing all the different documents and storing different document nodes into different objects. And then what I will be doing, like for every object I would be creating a different vector store. And so that like if the query comes and in the query I have asking question related to both like Uber and Lyft, then I should be navigate the query which is related to Uber to go to Uber vector store, and for the Lyft it should go to Lyft vector store. So we'll see how we can do that. So this is a function which I have written. So what it does, like it will take the nodes to get the base of nodes and the objects. Mostly in base nodes you have text nodes, and in objects you will have table nodes. So I'm creating a combined index where in one vector store I'm storing both the objects. One vector store I'm creating for table only. Okay. So for every for Uber or for Lyft or for NVIDIA, I will have these two vector stores. One which I will have both text plus table, one which will have table only. We'll see how it's performing. And then I'm just using a re-ranker, which is BG re-ranker large. And then I'm creating a separate query engine for both, one for combined index, one for table, and then just returning it. So what I'm doing, I'm just calling this function by passing all the nodes for like one for Uber and all. So I will get like two query engines for each document, for like Uber, for Lyft, for NVIDIA. So total 6 query engines I have. Then I'm creating sub question query engine. So what I will do, I will try to using QueryPipeline, I will create my own sub query engine RAG pipeline agent. But just to benchmark like how my agent will be performing as compared to the by default option given by LlamaIndex. So you have to import this subquery query engine. It also just creates a sub question and call different tools. So I'm just using it just to benchmark the performance. So what I'm doing, I'm just passing through 3 query engine tools, one for like Uber and the description, then for Lyft and the description, and the for NVIDIA, like this is the description. And I'm just passing the query engine also to this, and I'm just calling sub question query engine and passing this information here. Okay, now you can ask different question to this query engine. Then what I'm doing, I'm just creating my own PDF RAG agent to answer complex PDF questions related to text and table both. So first, what I'm doing, I'm just creating a tool choices, like similar way. I'm just passing the name of the tool and description, and I'm creating a different map, one for where I'm storing the query engine which has both text and table, and this is one which has only table, and we'll see how we are using it. Then what I'm doing, I'm just creating 2 different classes, one for sub question, one for sub question answer page. These are just to store the intermediate outputs. Then I'm creating different graph nodes. So like while creating a through query pipeline, you need to have different nodes. So different nodes can be your functions also, and then you just orchestrate like, okay, what is the first function, then from first function which second function you should be calling, and within function you can perform different tasks. So I will be building like RAG pipeline using these nodes, and we'll see how we're putting in between logic also, like to take a decision whether the agent should use like node A or node B. So that logic also we can. So first what we're doing, like we are calling creating a function which will generate sub questions. So first I'm calling LLM question generator, and I'm passing the LLM model, and then passing the tools which I have defined here, and I'm passing the query, and it will give me all the choices, like what are the sub questions, and for every sub question what is the tool we should be using to answer the sub question, that is given in these choices. And so like through this agent, what I'm trying to just replicate the same sub question query engine what only LlamaIndex gives, but when we are designing our own agent, it gives us the flexibility to modify the intermediate steps also. You can't do it here in sub question, it just works the way they have designed, but now the way we are designing our own, we have the option to customize it further, and with that we'll be doing in this video. Second is decide retriever. So this is a like a node which will decide which retriever to call, whether I want to call a retriever which will give me like answers from like context from text and table both, or or it will give me context from only table. So that's the decision I'm saying. So if just simple logic I put, if I see like keyword like 2021 in my query, then I will be just that means that I'm referring to get answer from some of the tables, and that's why I just call the table retriever. Like this is the basic logic I put. You can advance the logic, like if there's keywords like table in the query, or you can put more advanced logic also, like how you want to navigate between the different retrievers. Like there's one other option also, like you can get the answer from both the retrievers and then combine it like RAG fusion. So just I've given one idea, you can enhance this idea. So what it does, like if this 2021 is there in query, it will just set this flag as true. That means that it now I will navigate to retriever table instead of retrieve function, and I will get the context from table only. I will not get context from text. Then this node is which gives you the text and table context. So what we do is like whatever question map we have created here, we just loop through it, and from there we get the tool name, like what tool to use, what is the sub question we have, and then I'm just passing it to sub question like answer pages. This is a class which I've created to store the values what I have. So it will store my nodes which I'm retrieving. So this tool, if you see, this is a map which is this one. Based on the keyword, I will get any of these 3 tools, and I'm just using those tools to get the to retrieve the context by passing the question. So it will give me the like top 3. I think I've set top 10 here. If you see in this, yeah, it's top 10. So it will give me top 10 contexts from this vector store, and then I'm just re-ranking also. So it will give me top 5 only after re-ranking. So I will get the top 5 context from this tool. I will just store in the nodes, and I'm just storing into this class which I'll have the question and the nodes, and then I'm doing it for all the questions. Like if for a given query it has generated 3 different questions, like for all the 3 different tools, then I will just store all the 3 different loop through all the 3 different questions and get the context for every question and store in this Q question answer pair hop. And this I'm just passing this as output of this function call. Similarly for retrieve table, it will just I'm just changing this tool map, so it will call this one, like which will give me the context from table. So same way it will give me top 10, then based on the re-ranker I will get top 5, and I'm storing it again here. And also one thing, so I will get it here. Then what I'm doing is like then there's a response node which will take this question and the context as an input, and it will give me the answer from the LLM by I'm passing this prompt. So I will just looping through all the question answer pair. I will get the context from it. Then I will take the context and the question and will just format it using this QA prompt. And then I'm passing this information to this LLM.complete to get the response. And I'm just storing that information in the same class, like question will be part of sub question, answer will be part of this, and sources will be part of this. And I'm just appending into this QA pair all, and I'm just passing it. So now I have the sub question, the context what I got is here, and the response is part of this keyword. And then I'm passing these information to response synthesizer. So what it will do is that, like whatever question you ask, suppose, and it broken down to 3 sub questions. Now for every 3 sub questions you get the response. Now you want the response synthesizers to combine the response from 3 different sub questions into one. So that's the job it's being done by this. And finally it will give you the information like what was the query, what are the response, like context nodes we got, like the source nodes what we got, and the nodes will have the question answer pair information. So those things will be part of the response, and this is the final response we'll get at the end. So like nodes will have, if you see, it is calling construct node. So what it will have, it will the question and the answer, and source node will have the context information. So all 3 will be wrapped into response, and you can see how we're getting later. So now what we're doing, like using fn component, which is like class given by under QueryPipeline. If you see, this is given in QueryPipeline. What it does is it converts a function into this like QueryPipeline component. So you just pass the function name and then you get an object out of it, which are can be used as a node. So and then I'm just creating like one instance for every class, like every function, and then using QueryPipeline and first creating instance of it, like qp verbose is true, so it will show me what intermediate steps being called, and then I'm adding all the modules. So like these are my modules, which can be referred as nodes also. So I'm just passing all the modules here and passing the instance of it and the like a dictionary, like the keyword, and then I'm just creating a chain. So like how, like I want that from input I should go to generate sub question, from there I should go to decide retrieval, and then after decide retrieval I want to put a logic. If so, this decide retrieval gives me this flag, as you can see here, it gives me flag. So if the flag is true, I will call the retrieve table. If it's not true, then I will call this retrieve, which will retrieve text and table both. Then from there I'm just like I should go to response also, like retrieve should go to response, retrieve table also should go to response, and from response I should go to response synthesizer. So if you want to visualize, so this is a piece of code which can visualize the network what we have created using QueryPipeline. So this is how it looks like. From input I'm going to generate sub question, from decide retrieval I'm going to either table or retrieve, and then from both of them I can go to response and then response synthesizer. So now let's test this QueryPipeline, our agent. So first question what I'm asking is like, how is the cash paid for income tax net of refunds from supplementary disclosures of cash flow information for Uber. So now what it will do, first I'm querying, like passing this query to sub question engine, which is already given by LlamaIndex, and then I will pass it to my agent also. So first let's see what answer we are getting from sub question. So what it has done, like it just created one sub question only, it just kept the same question, and this is the output what we got. So it's saying $133 in 2019, $82 in 2020, $87 in 2021, which is right answer only. Like you can verify it to the PDF document. These are the PDF documents which we are using. Like it's 300-page PDF document, and which has a lot of different complex tables, as you can see, and we are asking different questions from here. Similarly, this is a table for NVIDIA, and similarly, we have one for Lyft. So now let's see what answer we are getting from our query pipeline. So it has invoked my query pipeline. Now you can see what it's doing. First, it's calling the input module, generate sub question, then it's going to decide retriever. From retriever, it said, okay, let me go to retrieve only, because we did not give like keyword like 2020 with this query. And then from there, it's going to the response, and this is what we are getting out. So it also gave the same output. So both the sub-query engine and the query pipeline are working good for this question. Second is like how much is the property and equipment net amount under assets, like for Uber under like for this date, like December 31, 2021. Let's see what answer we are getting from sub-query engine. So from there, it's saying $17 million. And if we check this in document, it should be like in 2021 it should be 1853. So the answer is not correct from subquery. Let's see what our query pipeline has gave. Yeah, I think it gave the right answer. So if you see from input, it go to generate sub question, then decide retriever, and from decide retriever it went to retrieve table. So it's not calling retrieve, which gives text and table both, and now it's only calling the table, and because of which we are getting the very right answer. So it gave me the right answer, confidence also. Then the third question is like how much is the short-term insurance reserves for like Uber in 2021. So if you see the subquery engine, it did not find the right answer. It just gave some text. But if you see the querying pipeline what I have, it gave me the right answer like 14442. If we check what is the value here in the document, you will find it's 14442. Now let's ask some more complicated questions from multiple documents. So the next question is like how much is the cash and cash equivalents under assets in 2021. I did not mention which document I'm referring. So what it will do, like let's test our sub question first, query engine. So what it does, like it will just create three different sub questions. First is like what is the cash and cash equivalent from assets in like Uber document. Second is like a Lyft document, and the other question is like an invoice. So I think that's the beauty of sub query question engine, which what is like it will see what all tools it's available, and based on the question, like if there is no specific tool mentioned, it will create sub question for all the different tools. So let's see what answer we got. Like it's 429555457 from Lyft, and NVIDIA is like $99 million. So now let's see what the response we got from our query pipeline engine. So this also created like three different sub questions. What is the cash equivalent for like Uber in 21, for Lyft, for NVIDIA, and as we have mentioned 2021 keyword there, so it's going to retrieve table only, and it fetched me the answer like 4295457 and 847. So I think one answer is not right from subquery engine. So let's quickly see the document. So if you just go to the document and let's search this cash and cash equivalents. So it should be 4295 from Uber. So I think it's right, 4295. Here also it's 4295. From it should be 847 from NVIDIA. And how much we got from NVIDIA is also like from subquery it's giving me 1990, which is not right. Like it's fetching me this. So I think there's confusion. So like which year we are referring, so it's like I've said 2021, so ideally should have given this, but it's giving this from subquery, but our query pipeline is giving right 8457, and for Lyft it's like 457 and 325. So if you see for Lyft, it's yeah 2021, where the year is first like 21 first 2020 later, so it's 457 325. So yeah, both the query engines have given me right answer for Lyft. Only for I think NVIDIA, I think there's a confusion for subquery engine. So in this part also our query pipeline worked well. It generated smartly three different questions, and for every question it knows which query engine it needs to fetch the answer from. Now let's test one more complicated question, like how much is research and development amount under costs and expenses. Now instead of referring two documents to one document, I'm just saying fetch me answer from Uber and Lyft, only two. So let's see if our query engine can pick this. So I think yes, query engine, it generated only two sub questions. Very good. It gave me some answer there. Query pipeline also, it generated two sub questions. For this is the second question, and it gave me this answer. So now let's see what is the right answer in the document. So we are referring to Uber and Lyft. So this is go to this is a Uber document. If you search here, yeah, research and development expenses and the cost and expenses is 21 is like 2054, and what we got from Uber is like 2054, correct. For our query pipeline also is correct. Right. Let's see what is this value for Lyft. So this is research and development expenses on the cost and expenses. If you see, 21 is the first part, 911946, and if you see, I think our query pipeline got the right answer, but I don't think subquery it got confused. 2.8 million is given. So I don't know, it's picking from somewhere else. So I think for all the different questions, sub questions, what you've seen, like our query pipeline is working the best. So by default options, what LlamaIndex provide, like sub question query engine, is not performing that well, and it might be because of multiple reasons. Like one is like we modified our query pipeline where if we see any keyword specific like to 2021, we know that we want our answers should be part of table, so that we're just querying the tables only, and that could be a bigger advantage. So that's why I just want to show in this video like how we can design our own custom agents like RAG agents which can work pretty well. And when you design your own, you have the option to customize different parts of it. So this is one way of doing it, but I feel that we can enhance it further, and so you guys can modify it further to make it more robust. So that's all what I wanted to show in this video. Thanks for watching the video. Please do share, like, and subscribe. Thank you.